triangle. If it is not a right angle triangle, then we have the standard representation of the triangle with a triangle like this. It is a triangle in which none of the side is right angle triangle. So like every triangle, this triangle does have three vertices. This is the first one. The first vertex is here. This is the second one, and it is the third one. These vertices may be named as A or PQR or in any other way, whichever is suitable. Now, at every vertex, angle is formed. So an angle is formed at A, other angle is formed at B, and the third angle is formed at C. Similarly, three vertices, three angles, we also have three sides in the triangle. The side which is in front of vertex A or angle A is side BC, and it is its length may be noted as the small letter A. Similarly, the side which is opposite of vertex B or angle B is side AC, and its length might be noted as small b. And lastly, the side which is opposite to vertex C or angle C is side AB, and its length might be noted as small c. So this is how the triangle which is not a right angle triangle is named and considered, and it is considered as a standard non-right angle triangle. Any of the angle is not the right angle here. Similarly, all the sides are unequal, and the way of naming the length of the sides is small letters A, B, and C. And how it is done? The side which was opposite to capital A was named as small a. The side which was opposite to capital B was named as small b. And the side which was opposite to capital C was named as small c. Now, since this triangle is not a right angle triangle, so Pythagoras theorem and the trigonometric ratios are not used here. So if we cannot use Pythagoras theorem and the trigonometric ratio, then two laws are used. The first one is called sine law. Sine law says that if you have a triangle like this, then the sine law would be written as sine of an angle, for example A, divided by the length of the opposite side, which is small a, equal to, again, the same ratio, sine of the other angle, for example B, and it would get divided by the length of the opposite side, which is small b, and it would be equal to the third ratio, where the remaining third angle, sine of capital C, would be written, and it would get divided by the length of the opposite side, which is small c. So these three ratios are equal to each other, and it is called the sine law. They are also written as the numerator of the ratio might be the length of a side divided by sine of the opposite angle. Similarly, b, small b divided by sine of capital B, and small c divided by sine of capital C. So the answer for every ratio would be same. So we can use these answers or these ratios as an equation. So 2 would be considered at a time, and we can find out the value of different unknowns using the sine law. Now, when do we use the sine law? Sine law is used when you don't have a right angle triangle and two angles are involved. Two angles are involved mean whether we are given with the values of two angles or we are given with the value of one angle and the other angle is required. So whenever two angles are involved and the triangle is not a right angle triangle, sine law is used. Similarly, the second important thing is cosine law. How do we write out the cosine law? Cosine law is written again in two forms. One of the form is when we have angle as a subject, and the other one would be when we have side as a subject. Let me use this triangle again. Okay. We have the same standard triangle, which is not a right angle triangle. So we want to write how can we write the cosine law for this triangle. So first I'm writing where the angle is the subject of the formula. So if I want to write the formula of cosine law for cos of angle A, then it would be equal to a fraction. In this fraction, the square of B and C would be positive, but the square of the side which is in front of the written angle is A, and the side in front of this angle is small a. Its square would be negative. And in the denominator, 2 would be written with the product of the two sides which were written as positive, means B and C. Similarly, if I want to write the formula with angle B, then two sides, square of the two sides would be written as positive, and the side which is in front of the written angle, its square would be written as negative, divided by 2 times A into C. Now, if you have understood the pattern, then it won't be difficult to write the third form. If I'm writing cos of angle C, then the square of A and B would be positive, but the side which is opposite to the written angle, which is small c, its square would be negative, and it would get divided by 2 times A into B. So these are the three forms of cosine law when we have written our angle as the subject. Now, the same cosine law could be written in another form, where we might have our sides as the subject. For example, I could write the same formula using a square, or making a square as the subject. The same formula could be written making b square as the subject, and the same could be written making c square as the subject. When a square is the subject, the other side would be b square plus c square minus 2 times b into c cos of angle A. So if we are writing for the formula for a square, the other two sides, the square of them would be added, and both of them would appear with a positive sign. Then there would be a negative sign, and 2 times the product of the same two sides would be written with 2, and cos would be written with the angle which is in front of the side which was written as the subject of the formula. Now the same is with B. I would be writing a square plus c square minus 2 times A into C cos of the angle which was in front of the side which was made the subject of the formula. So it would be capital B. Similarly, over here, I would be writing a square plus b square minus 2 times A into B cos of the angle capital C. So these are the 6 forms of the cosine law. It is used in the triangles which are not the right angle triangle, and it could be written in 2 different ways. One of the way where we made some angle our subject, and the other 3 forms where the sides were made as the subject of the formula.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it, and subscribing to our channel, and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.